So, Theorem 144 gives an equivalent condition for a sum to be direct. So, suppose that U1 through UM are subspaces of V. Then we have an if and only if. We have a direct sum if and only if. The following implication holds. U1 plus UM can add up to 0 only when all of the pieces are equal to 0. And I'll denote this implication right here with a purple star. Okay, and we refer to this whole implication here as a statement, which may or may not be true. Okay, so let's see. Proof. Let's prove this sucker. So for the forward direction of the proof, so we're going from left to right. So this means that we're assuming the sum is direct, right? So in other words, we're assuming the left-hand side of the implication. All right, so let's see then. Well, this is actually immediate from the definition of a direct sum. And the reason why is that we can always write 0 as a sum of zeros, and we know that we've got a 0 in each one of the components of the direct sum. And so then, since we are assuming, right, so our hypothesis here is that the sum is direct, that means that such a representation of 0 is unique, and so the only way to represent it is as the sum of zeros itself. And then that shows you that all the components, well, each one of these guys, each one of these things in the sum has to be equal to 0. Okay, so that does one direction. Yeah, okay, let me just write down. Okay, so by uniqueness, which comes in the definition of a direct sum, this is the only way to express 0. Okay. Okay, so let's see. So now if we look at the reverse implication, so for this part of the proof, our hypothesis is that this implication star is true. Okay, then let's see. So suppose we let V be an element of the sum. So then that means that V can be written as U1 plus plus UM with each little uj being an element of big UJ. All right, Suppose there was another way to write it. So suppose also that V looks like V1 added up through these other little V's. Where each Vj is in capital Uj. And so then now I've got these two equations. I've got let's see, the orange one and the indigo one, right? And so if I subtract the indigo from the orange, then on the left-hand side, I'm going to have V minus V. That's equal to 0, obviously. On the right-hand side, we have U1 added up through UM minus V1 added up through VM. And I can rearrange this using associativity and commutativity and whatnot to get U1 minus V1 added up through UM minus VM. Okay, so now by the hypothesis that we're assuming, namely that the implication star holds, well, since let's take a look at this expression here. We've got 0 expressed as this sum right here, and our hypothesis says that whenever you express 0 as a sum of things, each of those things has to be equal to 0. So in our case, we have Uj minus Vj equals 0 for each j. And I'm really looking forward to that guy being done with the chainsaw. Jesus. Okay. And so Uj equals Vj for each j. All right. And then that shows us that actually those two different ways that I had of writing V were the same. So there's only one. So we've got a direct sum. So we are done now by the definition of direct sum.